Hey, welcome back, and in this video we're going to continue on our series and deep diving into JavaScript at a bytecode level on the V8 engine. And in this video we're going to focus in on loops and conditional statements. So basically for loops, while loops, if statements, etc. And we're going to look at the various styles that you have in JavaScript and then how they translate and differ at a bytecode level. And where we're going to get super interesting is we're going to use the good old FizzBuzz programming exercises or sort of test code. And we'll sort of compare how FizzBuzz compares between the various styles and how the underlying bytecode is generating. And I think that's super interesting because I know a lot of people like a little bit of coding golf and sort of try and get the sort of most terse version of FizzBuzz in JavaScript. Well, this is a slightly different angle to this, and it allows you to go and have a look at, how the FizzBuzz that you create in your coding golf then translates down into actual bytecode and help you make some of those decisions as well. So I think it's going to be a lot of fun. If you don't know what FizzBuzz is, it's a programming exercise. It was popularized by Jeff Atwood back in 2007 and created by Imran Gori. If you want details on the history of FizzBuzz, then go check out my other video, which has got all the history of and how it became popularized. But FizzBuzz is a very simple game. It's basically based on a kid's game or a drinking game where everybody sits in a circle and then you shout out numbers typically from 1 to 100 in a programming exercise. So it's just like 1, 2, 3, 4, 5, 6, 7. But the difference is instead of shouting out every number, if the number is divisible by 3, you would shout out fizz. If it's divisible by 5, you would shout out buzz. And if it's divisible by 3 and 5, then you would shout out FizzBuzz. So a good example would be 1, 2, fizz, 4, buzz, fizz, 7, 8, fizz, buzz, 11, fizz, 13, 14, FizzBuzz. I think I'm right. We probably need to check that in the edit. So now that you know how the game is, let's go and code up a base level, right? A very, very simple example. And then we'll start comparing how the loop mechanisms all change as we try different styles. Alrighty, so the first thing I'm going to do is just open up my terminal. As you can see on my screen, I have an empty folder just now. So I am just going to open up VS Code. So we'll just do code dot. And what you'll see at the moment is we have a very, very empty folder. So I'm just going to create a new file. We will call this one, let's say, FizzBuzz.js. Okay, so that's just a nice empty JavaScript file. And then we'll create a function. We'll call that FizzBuzz. We're not going to pass in any values just now, and then I'm going to call my function here. I'm not going to use ES6 style syntax in this particular case. I'm just going to use typical function declarations. For the sake of simplicity, before we start replacing fizz and buzz everywhere, the first thing I'm going to do is just loop 1 to 100. So we're going to use a while loop in this case. We'll do fors and all that a little bit later on, but we'll just do let n equals 1, and then I'm going to while n is less than 101 because I want to loop 100 times. I want to get from 1 to 100. So we'll just create a code block there. I need to console log out what n is at that point. So that will give me 1, 2, 3, 4, 5, blah, blah, blah. And then I need to increment my while loop. So there we go. Now, I did say I wasn't going to use ES6 syntax, but you can see I'm clearly using a let statement, and that's good practice. So I'm just making it easier because I don't want to make the code a little bit more difficult than it needs to be, hence why I'm using function declarations. So if I just save that, so if I just come back to my terminal for a second, then I type in node fizzbuzz.js, you can see it comes back with 1 to 100. So that is cool. So I've got my while loop. Next thing I need to do is I want to start outputting fizz and then buzz. So let's do the simple example first. We will do an if statement. So we'll say if n is modulo 3. So what we mean by that is n divided by 3. If that has a remainder, right? That's what we're really looking for. So if I divide something by 3, if that has a remainder, then it's not a whole number, and therefore it's not divisible by 3. So if n modulo 3 should come back with a remainder. So let's say 4 modulo 3 would come back with 1 as an answer because it's basically got a remainder of 1. But something like 3 modulo 3 would come back with 0 because there's no remainder. So n modulo 3, and we'll do the triple equals here with 0, will tell us that it's something that's divisible by 3. So if I get that in that sense, then what I want to be able to do is just console log out, we'll say fizz in this case. And then if we don't have anything else, then we will just console log out the number. So we're starting to build up our case. If I come back to my terminal, run that again, you now see all the fizzes are coming true. So that's kind of cool. So the next thing I want to be able to do is check for 5s. So let's put that in here. So n 5. And in this case, what I'm going to do is console log out buzz. And then, of course, I'm just going to else that. I'm using the else if, and it's really interesting in FizzBuzz. You know, we as coders, we've dropped the else's and else ifs quite a bit, and we just use if statements a lot. And then because we're using functions all the time, we'll just kind of break the loop with a return. But actually in the case of FizzBuzz, then, you know, having that sort of if, else, if, etc., because I'm not doing any returns, is quite a nice structure. And we'll see later on how we get rid of that. But, you know, it's from a coding perspective, it's just useful to remember. It's a construct we don't often use, but it's just a nice reminder that it is useful in some scenarios. Okay, so if it's sort of modulo 3, then or divided by 3, then divisible by 3, then come back with fizz. If it's divisible by 5, then come back with buzz. So if I save that again, and then we run this again, you now see FizzBuzz, blah, blah, blah. Now I haven't dealt with the 3 and 5 scenario, because at the moment I will just end up with a fizz in that particular case. So what I need to do is just put in one more statement, which is probably going to be at the top here, and I'll just say if that is divided by 3 and it's divisible by 5, so we'll put an and statement there, divisible by 5, we'll put brackets around this, and then we can put FizzBuzz. So if it's both divisible by 3 and 5, it will say FizzBuzz. Otherwise, if I put an else here, it will be fizz or buzz or then the number. Okay, so if we just come back to my terminal a second, we can just make sure it ran okay. So I'm just going to clear all of this just to make it nice and simple, and I'll get rid of all of this as well. And if I just run node FizzBuzz JS, and if we scroll up a little bit, you should see it is now working. So 1, 2, fizz for 3, 4, buzz for the 5, fizz for the 6, 9 is fizz, 10 is buzz, 12 is fizz, and then FizzBuzz for 15. So our little routine is working there. So that's kind of cool. We're in a good space just now. We've got a working piece of code. So what we're going to do now is start looking at how this would work at a bytecode level, and then how it differs between the various loop constructs that we have. So we know that in JavaScript we have while, we have do while, we have for in, for of, etc. So let's start with the loops, and then we'll look at what's going on with the code underneath that. So the first thing I'm going to do is I want to simplify this out a little bit. So what I'm going to do here just now is I'm going to remove all of the code. I'm going to leave the console log in place, but I'm just going to toggle this lot here. So we'll just toggle the comments. And now all that's going to happen is it's just really going to go back to being an n and an n plus 1, right? So if I now clear this, and then we just do a node FizzBuzz, we're back to 1 to 100. Okay, so what we're going to do now is we're going to have a look at the bytecode that is generated by JavaScript. Now, I've done a whole set of other videos where we look at some of the bytecode and what all these symbols mean within there. Feel free to check those videos out. But the simple thing that you want to be able to understand is that, as you can kind of see there, there's a kind of node dash dash print bytecode, which means it's going to print out a bytecode. And then you've got this filter, which is print bytecode filter, and then you can put in your function name to filter on, just so you can reduce all the other things that's returned in the bytecode. And then of course you put in your name of your JavaScript file, which is FizzBuzz.js, and then that will come back with the bytecode. So if I return that, you can see it's generated 1 to 100, and then if I scroll up to the top here, so as you can kind of see from the code here, this is the underlying bytecode. I'm going to go through this very quickly, and then I'm going to simplify it a little bit, but there's a few things I kind of want you to point out. Is you can kind of see it's sort of loading the number 1 and the number 101, and really what it's sort of doing there is creating that range in the while loop, so you can go from n 1 to 101. You can kind of see it's doing a test there as well. This sort of all this junk here is calling the console.log. So you see console, and then you see log, and then the increment at the end here is the n++ that we had. So, and then you've got this sort of final check of sort of jump loop where it's jumping to B1. If we look over here, this is B1. So this thing at the end is really our kind of loop back to the beginning of our kind of while loop. So if you can see what's really going on, I'm not going to go into too much detail. You've got this idea of a loop. You run from here, the beginning of your code, all the way down. It does that console.log, and then you get to the bottom of your loop, and then you sort of jump back. And then if we come back to that test less than, then really it's doing a quick check against register 0. And then if you're not less than the number, then what it's going to do is jump to 44CE, which is down here. So that's going to break you out of the loop. So if we think about this from a bytecode perspective, bytecode doesn't really know much about things like loops. It's got a little bit of knowledge because JavaScript doesn't have things like goto statements. They don't exist in JavaScript as a language. So the only way you can kind of do a goto, which is really what's going on in the loop there, is when it's associated with a loop. So that's kind of why that jump loop exists in that sense. Now, if I come back into my code a second, if I actually just remove this console.log for a second, and then we run that code again, what you're going to see now is because I've removed the console.log, then it's not going to have all of that junk that's sort of doing the write out. But you see the code that kind of exists is left as it was before. So you've got this sort of load the number 1, load 101. You've got that check to see if if you're over the 101 value, and if you are, then it sort of breaks out. And then you've got that jump loop at the bottom there. So that's our while loop, and you can kind of see a while loop is really just this looping mechanism with a sort of test condition. If I wanted to, I could get rid of this test condition, the n less than 101, and I could just do a while 1, which gives me an infinite loop. And then if I go and generate the code again, I'm gonna be really quick and hit a Control-C. So if I just run that and then kill it, you can kind of, if you look at the code there, I've still got my 1, but you see that sort of test condition and that jump if false is disappeared in my latest version of the bytecode, because I don't need that anymore. There's no test condition, it's an infinite loop. But of course I still have that jump loop there, which represents the bottom of my code base. So you see jump loop, and then it's going to 4491. And if you look at 4491, it's back to loading whatever's in the accumulator from register 0. And then it's doing that sort of incrementing as we go along. So that still exists, and that represents loops. So if you think about it from a bytecode perspective, all while loops is essentially this sort of jump loop. That's really all it's doing. So it's a little bit of a kind of labeling and branching mechanism. Now, if I, rather than doing a while here, if I switch that here, if I move this while to down here, and then I do a do, so that's the other type of loop that you have in JavaScript. And then we just run that as well. So again, I'm going to do a Control-C very, very quickly. And if you look at that, the code in this sense is identical, right? It is literally identical. So load SMI *0, da 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 da. Identical. And the reason it's identical is a while loop and a do while loop are the same thing, right? The only difference is the test condition in a do while is at the bottom of a loop, whereas the test condition is at the top of a loop in a while loop. So in this sense, because I'm doing a while one, then they're going to be exactly the same. So if I were to bring this back to being n is being less than let's say 101 like I had before, and then I run this piece of code again. So if I look at the bytecode generated now, the thing that I want you to point out is if you see the increment there, which is my n++, the test condition, test less than, and then do a jump, is actually after the increment, right? Whereas when I did it as a while loop, so if I move the while back up here, you will see that that precedes, and we'll just run that again, you'll see that that precedes the increment in this case. So a do while and a while loop are exactly the same thing. The only difference is where the test condition is. So the test condition in a while loop is at the top, and in a do while loop, it is at the bottom of your code. So that gives you a bit of an idea of what's going on underneath. Now, what happens if I turn this into a for loop? So what I'm going to do here is I'm going to get rid of this, and then I'm going to do a for loop in here. Now, rather than doing my range of n less than 101, what I'm going to do is I'm going to generate an infinite for loop as well. And I can do that by doing empty statement, empty statement. That's what semicolon means in this sense. So I'm just generating an empty statement. I'm going to save that. And then I'm gonna run this code again, and then I'm gonna Control-C it because it's gonna go in an infinite loop. So I've killed that. And again, what I want you to see here is if you remember back to my infinite while loop, there's no test conditions. I'm just loading value 1 into the accumulator and storing it off in a register. I've still got this jump loop, so it's sort of jumping me back to 991, back to the top of the code block, and then it's doing the increment here, so it's just sort of going round and round. But there's no test conditions. But the key thing I want you to see there is the for loop is identical to a while loop when it's an infinite loop. It's absolutely identical. So there's just no test condition. Now, if I want to turn my for loop into something we would typically do, so I'm going to get rid of this let at the top there. I'm going to get rid of this n++. And now what I'm going to do is put my let n equals 1. I'm going to say n is going to be less than 101. And then I'm going to say n++. So this is back to a typical for loop style thing. And in this case, I'm probably just going to save that, and we will generate our bytecode again. So if I bring that up here, what you start to see there is you can see I've got my load small integer, test less than, jump if false, and then my increment is occurring, and then I'm doing my jump loop. The point that I'm sort of trying to get at here, and in fact, if I can make it a little bit easier by bringing the console log back in, and we just come back to the top. But if I bring that console log back in, all of that name property, call property, where it's calling the console log nonsense is back. That is occurring before the increment, but the test is at the beginning. Therefore, a for loop, if you look at this, is pretty much identical to a while loop. And that is a key thing to understand. So when you start to talk about FizzBuzz testing, should I use a while loop? Should I use a do while loop? Should I use a for loop? Well, from a bytecode level, they're pretty much identical. Now, there is some advantages of using a for loop, which is it's syntactically better, the scoping slightly better. So when I was in a while loop, I had to declare my let above the for statement there. So therefore, I could access the let outside of my code block. Whereas if I'm in a for statement here with a let n equals whatever, when I try and access that that variable n. So if I bring that up there, I'm going to get an error in this case because n is not defined. So there is some advantages of the scoping, right? Which is really happening at the parser level, not in the bytecode level. But as you can kind of see there, from an actual bytecode, from a loop perspective, while loops do while loops, and for loops are sort of identical in this sense. Now, if I actually even come back a second, right? Let's come back to a while loop for a second, and we'll do a kind of while one. So let's come back to that infinite loop. There's another thing that is supported in JavaScript as well, which is this idea of labels and the ability to use break and continues. So if I come back into my code for a second, one of the things I can actually do is I can give my while loop a label. So I could call it something like my loop. And you can kind of see that is now got a label, so that is that while loop here. And if I wanted to, I could I could actually start to control and build a while loop myself using the break and continue mechanisms if I wanted to. So if I put in an if statement here, and if I said if n is less than 101, then do an n++, and then if I did an else statement here, I said break, and then I could just break it, to be honest, but I'm going to put a break my loop, which is useful for nested loop scenarios. What should happen here is if n is greater than 100, so basically if it's 101, then what you're going to see is it's going to jump over to here, and then it's going to jump out of this console.log. So if I just move my console log here, in that sense, we're in a good position. And then if I run my code again, let's do this again. So we will, let me just check this, console log n. Let's run that. I need to define my n, which I've not done, obviously. So let's just put my let n equals 1. Let's run that again. You see, I'm back to running from I'm actually running from 2 to 101 in that sense, because I'm doing that sort of n++. So the final thing I need to do to run my code is I just want to move this console.log. I'm going to put it over here just so that we can see it works. I need to just put some braces around this as well. So we'll just put that there. Let's empty this out and just tidy that up a bit. If I now run my code there for a second, you see it's back to running from 1 to 100, which is what we wanted. I'm going to remove the console.log for a second, and then what we're going to do is look at the bytecode. So if I run that for a second, you can kind of see that the code is pretty much the same at this point. Test less than, jump if false, load it into the accumulator. I've got a couple of extra jumps there, and the reason I've got a couple of extra jumps is because I'm in control of my branches, so I'm doing if else, etc. So I'm sort of the one manually doing the breaks here, and then I'm sort of pushed back up to my loop, whereas the while loop just optimizes that a little bit when you're writing the code, but because I'm doing this while one. But it's pretty much the same thing. I can control all my branching through that labeling mechanism. So as far as the bytecode is concerned, it doesn't know anything about for loops, it doesn't know anything about while loops, and it certainly doesn't know anything about do while loops, right? It's just doing loops and labels and branches. That's really all that's happening. So when you're starting to think about these FizzBuzz challenges, should I use a for loop? Should I use a while loop? Should I use... The bytecode doesn't care, okay? It really doesn't care. So just sort of keep that in mind. So finally, before we sort of look at the if and the conditional statements, I think we've got a good handle of the loops just now. But I haven't covered the sort of for-ins and for-ofs statements. And the reason I haven't covered them in these cases is it doesn't make a lot of sense in JavaScript to do this. So for-ins and for-ofs allow you to essentially loop over arrays, allows you to loop over objects, etc. I'm sure we can cover that at another time. But all I'm doing in this case for FizzBuzz is just doing simple loops. Now, Other languages, so Rust is a good example, allows you to generate ranges. JavaScript doesn't have that native capability where you can generate ranges of values. If I wanted to, I kind of could do something with the for-in and sort of generate a range manually, but you're going to see, because ranges aren't supported natively by JavaScript, it's going to generate some pretty bad code. So what I'm going to do now quickly is just demonstrate that. So I'm just going to do a for-in. So if I just do a for n in, and then you can see what I'm going to do is create an array of up to 99. I'm just going to set the index value to whatever the key is, and I'll use the spread operator to fill that in. Let's just do a console.log of n, and then we'll save that out. And if I save that, so as you can see, if I just run that very quickly, you can see it's running from 0 to 98. So I could do a little bit of math there to sort of make that 1 to 99. I'm not going to do that for a second. But more importantly, if I look at the bytecode that's generated, it's a lot, right? It's a lot, which you would expect, right? I'm not going to go into detail of what's going on, but you start to see all of these kind of for-in next. You know, I'm creating arrays from iterables, etc. So it's creating very complicated code there. So there's no reason from any sort of sense in this particular use case, because it's a simple loop, to generate an array just so I can go for a range. You can do that in other languages, but it makes no sense in JavaScript, because if you look at the bytecode, you're making it more complicated and it's harder, and you're giving it more work to do. So just using a simple loop is probably the best way forward. So I think at the end of this bit, before we move into the kind of the for loops, I think into the conditionals, I think the thing to realize is that from a simplicity perspective, because my code, whether it's a while, do while, for loop, etc., is the same, I may as well just use a for loop, right? Have the most simple mechanism to the loop from 1 to 100. It's going to generate the same bytecode no matter what I do. So that's a kind of good stylistic stuff. Alrighty, so now we've covered loops fairly in depth, and you understand what's going on underneath the hood and bytecode level. Let's simplify our code and then just bring ourselves back into just having a for loop, because I think that we've decided that's the sort of simplest case that we can have. So I'm just going to type in there for let n equals 1, n is less than 101, and n plus plus. And there we go. We now have our kind of simple loop. And then I can just take my code that I had before. We'll get rid of all of this, and then we'll bring ourselves back into being a nice, simple kind of FizzBuzz scenario. So we will just untoggle this, and then I'm just going to console log out n as we did before. We'll save that, and then we will just clear this, and we'll run node.js, and we're back to running with a working FizzBuzz. So as you can kind of see there for a second, and we're going to start covering the if statements now. What I want to sort of look at is this sort of if-else combination, right? So I'm doing an if this, else, else. Let's have a look at this, what's going on underneath the hood from a JavaScript perspective for bytecode. So to do that, I think the first thing I'm going to do is I'm going to get rid of the for loop again. I know we've just sort of recreated that, and we're going to focus on the if statements for a second and then understand that, and then we'll build ourselves back up. So I'm going to get rid of all of the else ifs in this sense, and we're just going to bring ourselves back to having a nice simple if statement. Now, at the moment, I don't really want to worry about the ampersands and the modulos for a second. So I think we will just do look for fizz at the moment. So all we're going to do is if n3 triple equals 0 console log FizzBuzz. So if I come back into my code for a second, let's do node FizzBuzz.js for a second again there. N is not defined, and that's because I got rid of my my code. So I'll just put my for loop. So I'll put n equals 1. Let's do node, and then we will bring up the bytecode. So if we look at the bytecode underneath that, there's a few things I want you to kind of start to look at here. So I'm loading my value 1 that we did there. So the next thing you're seeing this mod SMI. So that is this here. So this n divided by 3, so or a modulo in this case, is sort of done here against the accumulator. So mod SMI by 3. So that's my kind of key thing there. If I was going to do a 5 in that case, let's sort of do this again. You should see that 3 will now become a 5, which is kind of cool. So that's sort of nice. The next thing is, once it's done the modulo, it's going to get the result. So the result from doing that calculation is going to be stored in the accumulator, and then that will be stored in register 1. And then what it's going to do here is do a test equals strict on R1 on register 1, and it's going to basically see if it's equal to 0. So it's testing if R1 is equal to the 0 in the accumulator. And then finally, we're going to do a jump if false there. So that's kind of what's going on with that if statement there. It is pretty sort of simple stuff. I think one of the things you could probably understand is an optimization. I've put this to FizzBuzz at the moment, but if I were to kind of put this statements in here, if I brought this back to being N3, N5 like we've got over here, let's do that for a second, and then open up the bytecode. You're going to start to see that gets quite complicated quite quickly. Mod SMI, jump. So I think if I was being truly efficient in my FizzBuzz scenario, rather than doing a modulo 3 than a modulo 5, I think a more efficient thing to do in this case would be to do a modulo 15 in that case. And therefore, because if it's divisible by 3 and it's divisible by 5 as well, it's going to be divisible by 15. So if I run that again, and you can now see the modulo 15. So I've brought that down to 1 operation in the bytecode. So that is an optimization you can make if you were playing kind of code golf with that. I would argue, why would you bother? I think the speed of computing these days, etc., I just don't think it's going to make much of a difference. And these are not the things to be focusing on in your code. But I really just, what I'm trying to do is show you the effects in your bytecode. But there we go. Now, the other thing that's probably relevant there is you see this sort of test equal. It's the same sort of branching mechanisms that we saw in for loops and while loops, and then the jump if false. But you see it's using a test equals strict there. So, and that's because I'm using the triple equal symbol. If I switch that to a double equals, right, which I can do because I'm just dealing with numbers, I'm not dealing with objects, etc. Then if I just do that for a second, run that again, you see rather than doing a test equal strict, I'm now just doing a test equal. So you can kind of see what's going on underneath what we're doing here is we're using a slightly different opcode from depending on whether we use a triple equals or a double equals. So it's just something to kind of be aware of. So there we go. I've got my FizzBuzz. And that sort of leads us into the next bit, all the else's, etc. I kind of like having the else's in there. You can do a FizzBuzz where it's a little bit less complicated, but I think the else ifs are kind of good in this sense. So if I were to just let's toggle all of these lines for a second, and then we open that back up there, and then we bring our FizzBuzz back. We have a look at this. All you're going to see there is you've just got a sort of repetition of code. It's calling console.log, calling.console.log, but all we're sort of doing is this sort of combination of test equal and then doing a jump, right? And then if you look at the jump code, that's to 56C, which is down here where it's calling the code. So all of this these are just code blocks in your bytecode. So you're going to have basically 4 code blocks, one for FizzBuzz, one for Fizz, one for Buzz, and one for console.log. And then all that you've got for each one of these code blocks is you're going to have a test. Yeah, so test, and then if the conditions meet, then it's going to do a jump. And you can kind of see that sort of consistently across the board, which is test equal, test equal. I'm sure there's another one kicking around there. Test equal, and then jump, jump, jump. So we're in this sort of constant. That's how the mechanism works. It's just jumps and test equals in that sense. So that's kind of how it looks. I think you've got a fair understanding of how the if statements and the else statements work in that sense, and that's kind of cool. So as you can kind of see there is a little bit of an inefficiency that is going on in my code, and that inefficiency is basically because I'm calling console.log like 4 times and I'm doing a check if time. So one of the things that a lot of people do when they're doing a FizzBuzz is they use what's called the ternary operator. So we're going to do the same, right? We'll do an if else as a ternary. We'll have a look at that, and then we'll try and kind of compute out what's going on. So I'm just gonna sort of toggle these out for a second. And what we're going to do is start to build up that sort of ternary operation. So if you haven't seen the ternary operator before, it's like an if statement. It's basically got an if and an else part, but it's in a much more compact form. So what we're going to do now is we're going to use that ternary operator and then see how we can make our code a little bit more efficient. So the first thing I'm going to do is I'm going to bring my for loop back because I really want it back. I'm going to get rid of this let statement for just now. So we'll just comment that out because I'm probably going to need that later. And then what I'm going to do is just check for fizz. So I'm going to do a console.log because I want to output my result. And I'm going to do my modulo 3 as I did before. So we'll just do n modulo 3. And if that is equal to 0, then what I want to do is return fizz. And if it's not got anything coming back, so if it's not divisible by 3 at the moment, we'll worry about FizzBuzz and all that a little bit later. I just want to return n for just now, so we'll do that. And then what we should do is if we run the code, then what we should see is we've got fizz all the way down there. So that's pretty cool so far. Now, what I can do is get a little bit cleverer in this sense. So in the same way as I did the n divided by or modulo 3 coming back with fizz, I can do the same but with buzz. So if I do n modulo 5 equals 0, and then we'll just make that equal to buzz, and that's going to be pretty cool as well. So that's going to add that together. Now, what I don't want to happen is in this particular case, I don't want the n to be returned, because if the n is returned, then it's going to mess up my numbers. So what I'm going to do is have an empty string in this case. And that's pretty cool, because if I've got an empty string there, if you see there, that's fizz, and then I'm going to add over here to whatever buzz is. So if it's 3, it's going to come back with fizz. If it's nothing, it's going to be an empty string. If it's modulo 5, then it's going to come back with buzz, and therefore I'm going to want an empty string there as well. So I'm just going to do that, and that also gives me FizzBuzz. And we'll cover the last bit in a second. So if I run that code again, you can kind of see I've got FizzBuzz, and I've got my FizzBuzzes there, but I don't have my numbers. But what I do have at the moment is empty strings. So if I just take all of this, we'll put another bracket around this, and then I'm just going to add an empty string again. And then what you will see, and then what I'm going to do is I'm going to put an OR statement on that. So we'll just do that. And then I'm going to put n there. And what that's basically meaning is that if I've got an empty string, if there's no value in this case, if I've got a value, then show fizz or FizzBuzz or whatever. But if I've got no value, then show my number n. So if I run this and run node FizzBuzz, you see I'm back to running the way I was, right? I've got FizzBuzz for 15, I've got fizz for 9, buzz for 10, so it's all sort of back in a good space. And it's a little bit more terse, and it's and I've got rid of all of these different console logs, and I've brought it down to 1. I'm not having to check multiple times. I've just got sort of a check on 3, and I've got a check on 5. So how does the ternary operator look like in bytecode? Well, let's just clear this for a second, and we can have a look at what that looks like with our bytecode. So if I just run that for a second and then come back up to the top here, we can see what the bytecode looks like. And as you can see, it's still quite large, but it's not massive, right? I've still got all my console.log nonsense that I had before, call property, blah, blah, blah. But actually, I've got my mod SMI, so here's my modulo on the 3. Here's my modulo on the 5, and you can see the ternary operator in this case is just doing a check on Boolean. So you've got this sort of jump if false, jumps, etc. So even though you're using a different syntax in the bytecode, it's just translating back down into jumps as we did before. So jump if false, jumps, blah, blah, blah. So it's fairly efficient. It's a little bit of sort of syntactic sugar in this sense. So it's pretty cool, and it's generating you an efficient set of bytecode. So that's kind of where we are on this case. So I think that's a good optimization to make, so we can get rid of all of this nonsense over here, and we've got ourselves down into some pretty neat code that generates efficient bytecode, but also is pretty much small in size. Now, one of the things a lot of people then do is they try and get it down to the smallest size possible. So I'm gonna sort of get rid of this lot here for a second, and then you can start to play games if you were into sort of coding golf, where you sort of try and bring it into one line of code as I've done here. And then you're kind of good to go. So if I save that, and if we just look at the size of the file here, you can kind of see that this is sort of 85 bytes, which isn't bad. Now, if you were going to be absolutely insane about this, you could bring it down even further. I think the smallest I've got it down to is about 62 bytes or something like that, which was quite painful to do. But of course, if you want to indulge the madness, you can. So best I've managed to do, and I've just sort of copied it in my screen, and actually I got as far as 66 bytes, and then I saw somebody else use an interesting technique, so I've copied that in this case. It's a little bit of a crazy technique if you really want to do this, but again, please sort of try and avoid doing this if you can. But the basic technique in this sense is what you've got here is you're getting rid of the extra kind of the n++, and then what you're doing here is within your statement is doing a ++ n is less than 101. So you're doing your increment over here, which is the interesting technique. And then what you're now doing is moving your console log into where normally you would do the iteration, where you're doing the n++, because this is just a statement which is allowing execution. And then if you look at the body that you've got here, you're doing your n modulo 3, and if that is equal to fizz, that's coming back as a empty statement there. And then because that's being stored in f, then you're using this sort of ternary operator to then do the n modulo 5 check against the f. So you're seeing if that's been it's got a fizz in there or not. And then you're doing the or statement against there, and then that allows you to put the buzz in. So it's using a sort of really horrible techniques of things that are supported in the for loop, and you can kind of see that. So if you look here for a second, you'll see that brings it down to 62 bytes. Again, if I were to run this for a second, you see it works. It's generating FizzBuzz where it should. So we were to look at some of the underlying bytecode of this, and I'll just bring this up for a second. You see FizzBuzz works as it did before. You're not really gaining anything. It's kind of equivalent to what you've got, but it's some fairly nasty stuff. You've got some jump ifs, etc. A bunch of stuff moves around. You got the loops there. So is the bytecode any more efficient than it was before? Not really, no. So I don't really see what you're gaining there. But again, you can mess around and you can have fun with it. That's not really the point of this video anyway. The point of this video is not for you to sort of sit and optimize your code and play code golf. The point of this video is for you to really understand the if statements and the for loops and ternary operators and how, for, and whiles and all that compile. But I hope you get the idea that when you're playing something like coding katas or coding golf, etc., it's a lot of fun to do these optimizations. But the most important thing that you can do is write code that is completely readable. Because if you come back to the code that we generated before, if I look at the line that I had, this for loop is completely unreadable. How do you expect somebody to understand the nuances of what's going on there? Whereas a very simple for loop with a bunch of if-else statements, really easy to read and understand. You're not gaining anything by trying to save file size. You're not gaining anything by trying to get all of those little tiny optimizations from the bytecode. As we saw, they're roughly the same. So the best thing that you can do is write vaguely efficient code, but write in a nice style where people can understand your code, where it's very readable, and not focus on like the nth degree of performance optimizations, because you may have cut down the file size, that's for sure, but you may end up messing up the bytecode underneath. So write good code, write clean code that is understandable, and focus on that. Have fun with coding katas, have fun with coding golf, but don't obsess with it. And people that turn around and say, hey, this is better for this reason, or this is better for that reason, you know, it probably isn't when you get down to a bytecode level. So just kind of be aware of that. Anyway, I hope you've enjoyed this video. I hope you managed to get a sort of deeper understanding of what's happening under the hood with if statements and branching and for loops and while loops, etc. And that's giving you that sort of deeper level of what's going on. And anyway, we'll speak soon. Thanks very much.